It's a very common question that everyone has how it is taught in engineering colleges in India. Usually, in India, each college is affiliated to a particular university, and the university determines the syllabus and the exam criteria for each course. So, each college will have a lot of courses, and the syllabus for that will be provided by the university. And we can buy these syllabuses from bookstores. So there will be couple of bookstores near to the college most often, and we can get the syllabus from there. And also the textbooks. Same goes for textbooks as well. The professors will recommend particular textbooks, and we can get those textbooks from the bookstores. So the books will serve as a guide, and the professors will also provide guidance through their lectures in the classrooms. So, with the help of the lectures and the syllabus, we can identify which portions in the textbook we need to provide more focus on so that we can get maximum marks in the exam. For example, this is the book we used for environmental engineering 1, paper 1, and this mainly deals with water supply engineering. So it's a book written by this book has three authors: BC Punmia, Ashok Jain, Arun Jain, and it has about 17 chapters. So for this particular paper, Environmental Engineering 1, we probably won't learn everything from all the 17 chapters. So we have to compare our syllabus with what is given in each chapter, and also the guidance we receive from the professors. We will be able to know what we should learn for the exam. So probably each chapter will have at least few portions. For example, if you look at chapter, this is a sample question paper I have here for environmental engineering 1. This test was taken during the 7th semester. So, how the exam is arranged is that there are two sections, part A and part B. Part A has 10 questions, 4 marks each, and we need to answer all the questions. And part B, there are about 5 questions, and each of these questions have a choice. For example, for each question, two choices are given, and we can pick one or the other. And each question carries 12 marks. So 5 multiplied by 12, 60 marks, and then total 100 marks. 100 marks. So, for example, the second question here is there are two questions. For each number, there are two questions, A and B, and we can choose either A or B for our answers. What are the various methods for forecasting population? Describe any three methods with their relative advantages and disadvantages. And the next question is, what do you understand by demand curve? Explain the method of calculating reservoir capacity for a specific yield from the mass inflow curve. So these are two questions given A and B for question number 2. So we can pick to answer either of these questions. The graphs, charts, tables, etc. that we need to use for the test, it's also provided along with the question paper. And the test is about 3 hours long. Here in this sedimentation chapter, it mostly deals with how to calculate settling velocity of sediment particles, and also how to design different kinds of sedimentation tanks. So first, let's look at all the technical terms. The terms: sedimentation, plain sedimentation, sedimentation with coagulation, chemical precipitation, discrete particles, discrete settling, hindered settling, fluid mass, density, weight, volume, drag force, drag coefficient, specific gravity, Reynolds number, impelling force, weight, diameter, sphere, velocity, viscosity, kinematic viscosity, viscous fluid force, force of inertia, centistoke, centimeter, seconds, millimeter, gravitational constant, Smith's values, turbulent flow, transition flow, laminar flow, Newton's law and Stokes law for settling velocity, displacement velocity, volume of sphere, area of sphere, inlet, outlet, settling tank, sludge, two types of sedimentation tanks, fill and draw, continuous flow. Vertical cross section, horizontal cross section, length, depth, width, height, area, volume, discharge rate, area of tank, surface area, vertical or cross sectional area of the tank, detention period, flowing through period, suspension of particles, flocculent solids, friction factor, displacement efficiency, velocity, surface loading, plane sedimentation, horizontal flow, vertical flow, clarifiers, inlet arrangement, outlet arrangement, effluent launder, wear plate, discharge, turbidity, unit JTU, different kinds of currents, eddy currents, surface currents, vertical convection currents, density currents. Sedimentation tanks, rectangular tanks, circular tanks with radial or spiral flow, hopper bottom tank with the vertical flow, velocity gradient, sedimentation with coagulation, coagulants, mixing devices, centrifugal pump, compressed air agitation, narrow mixing chamber with the fluid, mixing basins with the baffle valves, mixing basins with mechanical devices, power expressed in watts, gradient velocity, flocculation, parts of devices, rotor blades, shaft, stator blades, chemical feed, sludge discharge, baffle, effluent, clarifier, flash mixers. Flocculation. What is flocculation? I think there is some kind of confusion here. What is given in this textbook is flocculation is essentially an operation designed to force agitation in the fluid and induce coagulation. Basically, flocculation is a slow mixing or agitating process in which de-established colloidal particles, no, destabilized, destabilized colloidal particles are brought into intimate contact in order to promote their agglomeration. So that is known as flocculation. And the operation of slow mixing is achieved in a basin commonly known as flocculator. So that is what flocculation means. And I don't think it is really visible here. This is the diagram I have in this book for uh, mixing basin, flocculator, and settling basin. So this is this diagram. And then I also have diagram here showing flocculator with mechanical agitators. So when we go through these terms, probably there is a way to show this in a better way. So it shows both the longitudinal section and the cross section. So it is important that we need to get familiar with these all the terms before starting to read the text. So it's mostly going through some text and understanding the process, and it's a lot of problems here to solve. So as I said, the initial section is mostly about calculating settling velocity using different equations. Finding the settling velocity. So the settling velocity is primarily dependent upon the diameter of the particle. So as you know, the particles are not often, so the equations, it assumes spherical shape. Most often the particles are assumed to be spherical shape, but then that's not true. So the equations vary based on the shape of the shape of the particles sort of play a major role in the equation. So the equation varies little bit. It's mostly familiarizing with those equations and learning to calculate the settling velocity. That's the first part here. And then the second part is mostly about the sedimentation tanks. So how do you design a sedimentation tank? So for that, first you need to get familiar with different parts of the sedimentation tank, and it has a lot of examples here illustrating how to design various components of the tank. See here, there is an example given for design of rectangular plane sedimentation tank. So all the data is given, and this is done in a very orderly fashion where we can understand each and every concept. So the first is the design elements is calculated here. Required outflow rate, water loss, design average flow, and then the second stage is computation of settling velocity of minimum size particles. Stokes law is used here, and the third step, determination of surface overflow rate. Fourth, determination of dimensions of the tank. Fifth stage, check against score. And sixth, design of influence structure. Design of effluent structure. So here, that's the last step. So here it completes. So many equations are used in this whole problem. So if we understand each and everything in this problem and each of the technical terms and how it is done, probably it will sort of cover the most part of this chapter. And the next question is radial circular plane sedimentation tank. Mechanical rapid mix unit, peripheral effluent loader. So that is part of another question. Okay, actually design of radial circular plane sedimentation tank. So it has different parts. There are 5 steps here. Design elements, design of influent pipe, computation of settling velocity, minimum size block, determination of surface overflow rate, determination of dimensions of the tank, design of peripheral effluent launcher. Those are the 5 stages here. Then the next is design of mechanical rapid mix unit. So it has first step, design parameters. Second, determination of dimensions of the tank. Third, computation of power requirements. Fourth, determination of dimensions of flat blades and impeller. And then next is about uh, designing a flockulator. So designing a flockulator, there are 5 stages. Design, the first step we are going to find all the design parameters, then computation of volume of flocculation tank, computation of power required, computation of velocity differential between the puddle and water, computation of paddle size. So these many problems are given. So if you learn to solve all these problems, then pretty good at uh, designing sedimentation tanks, theoretically. Yeah. And then we have a lot of questions here. Uh, so this includes questions which are asked for civil service exam also. Means these are questions from the previous exams. From the previous exams of so there are about 29 questions here, and a few of the questions are from the previous civil services exam for engineering services.